Good evening and hello. We are back for section 8.3, chapter 8, section 3, page 590 in our textbook. Continuing on with polynomial and rational functions, where we are going to be, first of all, evaluating the function at a point. So let's see here. Let's just get right into it. This is a short section. I have 4 examples here. And basically we are just evaluating these functions. So for examples 1 and 2, if p of x equals 3x raised to the 4th power, I'm going to rewrite this because on my keyboard or this program, the Paint program, I'm able to write the exponents with the caret raised to the 4th. So this is the same as 3x to the 4th minus 2x squared minus 5. Okay, and of course this is the function p of x. Okay, and what they want us to do here is to evaluate it at p of 1. So I'll use the notation, the function notation, p of 1. So that will equal 3 times 1 in parentheses to the 4th power minus 2 times 1 in parentheses raised to the 2nd power minus 5. Okay, 1 to the 4th power is 1. 3 times 1 is 3. 1 to the 2nd power is 1. Negative 2 times 1 is negative 2. And then minus 5. Minus 5. So this evaluates to be, let me make sure we see that as a 5. 3 minus 2 is 1, and 1 minus 5 is negative 4. Okay, and that's what it evaluates to. The second number that they're using is p negative 2, p of negative 2 equals, and it'll be the same thing. So it's going to be 3 times negative 2. Now I definitely want that in parentheses, raised to the 4th power, minus 2 to the negative 2, raised to the 2nd power, minus 5. Okay, so what does this evaluate to? So now, you can use your calculator, of course, but I like doing things manually. So I got negative 2 to the 4th power, which is negative 2 times negative 2 times negative 2 times negative 2, which is 16. And 16 times 3 is 48. Okay. Negative 2 to the 2nd power is 4. 4 times negative 2 is negative 8. And finally, the minus 5. All right, so that ends up being 48 minus 8, which is 40, minus 5, which is 35. And there you have it. Using function notation and doing my substitution, I evaluate the functions and I get my correct answers. Hello. All right, let me move on here. To our next problem. It says the largest natural bridge is in the canyons at the base of Navajo Mountain in Utah. From the base, couple of typos here. From the base to the top of the arch, it measures 290 feet. Neglecting air resistance, the height of an object dropped off the bridge is given by the polynomial function negative 16t to the 2nd plus 290. Find the height of the object at time t equals 0 seconds and t equals 2 seconds. All right, the largest natural bridge. So you've got some kind of a bridge here. Let's make this the bridge. From the top of the arch, it measures 290 feet. Okay, it's from the top of the arch. Is it, what are they saying here? The bridge is, well, it doesn't matter. So I could just say here's the bridge. And then if this is the top of the arch here, then from the top of the arch, from the base to the top of the arch, here's the base down here. If this is water, perhaps, I can make some waves here. So we know from here to here it's 290 feet. Okay, neglecting air resistance, the height of the object dropped off the bridge is given by this polynomial function. Find the height of the object at t equals 0 seconds and t equals 2 seconds. All right, so here I've got negative 16 t to the second power plus the 290. Okay, at 0 seconds, meaning no time has passed, what's the height going to be? Well, that's pretty easy to think about. It's negative 16 times 0 for time squared. You know, go through the formalities here. 290, so it's going to be 0 plus 290. So the height is 290. Okay, that's rational. Then what is the height after 2 seconds is the second part of this. Okay, after 2 seconds, I'm going to take that same equation and plug in 2 for t. So I got negative 16 times 2 to the second power plus the 290. Okay, 2 to the second power is 4, so negative 16 times 4 is negative 64 plus 290. All right, I'll just subtract the 64, and I've got 6 and 2 and 2. So the height of the object is 226 feet. Okay, that was for part 2. Here, our last exercise, practice exercise, is practice problem 4. When we're going to deal with rational functions here. Rational functions in fraction form is a rational function. Rational, and from the word rational, we have ratio. It's kind of an interesting way of denoting what this problem looks like. Rational functions are polynomials in fraction form, or fractions in polynomial with polynomials in it. So here I've got numerator, denominator, and using this rational function, it says a company's cost per book for printing X particular books is given by the rational function. This is what it costs them to print a certain number of books. So find the cost per book for printing 100 books. So we'll use this function here to evaluate it first of all. So down here I could write this as the cost C of, in functional notation, would be C of 100. That equals, I got to write that a little bigger. So I could write this for A. So it is C 100. That equals 0.8 times 100 plus 5,000, and all that's divided by 100. 100. Okay. Okay, so this ends up being, in my calculation, I could say this is going to end up being, well, 0.8 times 100 is 80 plus 5,000, so that's 5,080 divided by the 100. And when I divide this out, let's see what we get here. Divided by 100 should be 50.8. All right, so the cost of 100 books is $50.80. I should put it like this with my dollar sign. And that would be for each book. B, what's the cost of 1,000 books? So I could do this as C, and it's going to be, let's see, 1,000, C of 1,000 equals, and I'll substitute the 1,000 for the X given my function up here. That's going to be 0.8 times 1,000 plus 5,000 divided by 1,000. Okay, when I calculate this out, this should end up equaling $5.80 per book. Okay, so this is, would you say 800? 800 plus 5,000. So you got 5,800. And then divide that by your 1,000. And that's what you get, 5.80. Okay, that's it for this short section. And I hope you found that to be very easy. Okay, see you next time.